Hey guys, so last I left you, there was this one problem that I actually couldn't solve in the video. It was the evaluating limits via factoring and conjugation. Now there was this one problem, 6C, that I couldn't handle at the end of the video, so I had to stop right there. So I thought about it a little bit, and I figured, you know what, I'll hack away at it again, and maybe I can come up with an answer this time to this limit. So it's limit as x approaches 1. I'm going to call this a funny limit because I was actually stumped. Um, Root x and cubed root of x minus 1. Okay, now here's what we have to remember before we proceed. There's going to be a little bit of conjugation. There's also a neat little trick that I could use. I have to first note, okay, that that the cubed root of x cubed, right, is equal to x. All right, so I have to note that, right, because the cubed root and the cube undo each other. Okay. Now watch how this is meaningful. Watch how this kind of helps the situation. 1 cubed is 1, right? Now, we've broken something like this up before, right? So what we ended up getting was the cubed root of x minus 1, right? And then we got a factor of cubed root of x squared, okay? Oops. No, that's correct. Plus the cubed root of x, okay, plus 1. All right, so this is the a cubed minus b cubed equals a minus b times a squared plus ab plus b squared rule. Okay, so I'm literally using this rule where a is the cubed root of x and b is 1. Okay, so try to follow along and I get this guy. All right, now the reason why that's important is because I can rearrange for this factor, right, which appears in my question. All right, so this is going to be such that root x minus 1 equals cubed root of x cubed minus 1 cubed, right, or just 1, over this monstrosity. Okay, so we get this. All right, now in the question it's actually the reciprocal. It's 1 over this, right? So I just have to reciprocate it and I can plug it in. So I'm going to do that. Okay, so I'm going to switch everything up. So let's see, on the bottom now I get this guy, right, the numerator, okay, minus 1 cubed, and on the top I get root of x minus 1, but I also get this guy. Now notice, even though this is on the bottom in this guy, it appears in the top here because I've got this term that I substituted for in the bottom. So I got to reciprocate, right? So that's why this guy now appears on the top. So root of x, cubed root of x squared plus cubed root of x plus 1. Okay, now we're not done, all right? Because what I'm going to do is I'm going to also multiply by the conjugate of the numerator. So it's going to be root x plus 1, root x plus 1. Okay? Now, here's where it gets juicy. The cubed root of x cubed is just x. So I get x, and now 1 cubed is just 1, so x minus 1 is what appears in the bottom. Now, if I group this guy with this guy, okay, that's a minus b times a plus b. So I'm going to get a squared minus b squared, and that's x minus 1, right? So I get my term that I needed to cancel, right? So it's gone. So what's left is this thing, right? And this thing in the bottom. So this is what I have left. How beautiful is this? Okay, it's a neat little trick that I did in order to solve the problem, right? I don't even think I needed this bracket. And I get root x plus 1. Now, this is all that is left, right? This square bracket stuff that I just highlighted here. So all I have to do is plug in 1. So if I plug in 1 into this first term, I get 1, 1, obviously 1. So you get 1 plus 1 plus 1. And then at the bottom, I get 1 plus 1. That's 2. So I get a final answer for this limit of 3 over 2. And that's the problem that stooped me in the past video. I'll have a link to that video. As usual, please like, comment, subscribe, share this video. And yeah, thank you so much for tuning in. We love you guys, and hope this helps the situation. Thank you so much. Bye.